So this video is going to be all about proportions drawn from a single sample, and we're going to cover both hypothesis testing and confidence intervals. First example, there is concern that the proportion of college students who smoke cigarettes is increasing. So the random sample of 100 college students identified 23 smokers. What does this say about the population proportion? Well, the sample proportion was 0.23 or 23%. There's no guarantee that if you were to do the experiment again with the same sample size, that you would again get 23%. Sample proportions vary all over the place. Sometimes you'll get 17%, sometimes you'll get 28%. So what we need is something called a confidence interval. And that's what we're going to do. We're going to get a 95% confidence interval for the population proportion of college students who smoke using this data, 23 out of 100. So I'm going to pick up StatCrunch, and I'm going to go under Stat, and I'm going to pick Proportion Stats, one sample with the summary. The number of successes, smoking isn't a success, but we'll go with it, is 23 out of 100. And we're going to get a 95% confidence interval and compute. So there we have it. This is something that we're 95% confident of. And it's in decimal form, but I'm going to say it in percent form. We always start off with a statement, we are 95% confident. Give your confidence level. We are 95% confident that somewhere between 14.7% and 31.2% of college students smoke cigarettes. So that's a pretty wide confidence interval. Okay? So it's a good thing we didn't just stick with the 23%. There's a lot more that can be said. We're 95% confident that the true percentage of college students that smoke cigarettes is somewhere between 14.7 and 31%. So as you can imagine, I have another example for you. This time, we're trying to see if John's belief that 50% of first-time brides are younger than their grooms. So that's a pretty strong statement from John. He really believes that's true, that brides are younger than their grooms. So someone did a sample, and they found that 50%, they found that 53 of the time of the people surveyed were first-time brides, and the sample size was 100. So what we've got going here is we've got a hypothesis test, okay? And the hypothesis is that we're going to say that John is, we're not going to contradict John. A null hypothesis always has an equal sign, and it says nothing has happened. We have no reason to believe John is wrong, but we've got some data, 53 out of 100, and we're going to they have as a null hypothesis, it's not 50%. So we're going to do that live in StatCrunch. We're going to pick up stat, and again, proportion stats, one sample with the summary. 53 out of 100 was our sample data. Our null hypothesis was, going along with John, that the proportion of first-time weddings, the bride was younger, or it's not the case. So let's compute this and see what happens. What happens is not a good thing. We never reject, if the significance level is set at 0.05, 50%, suppose it is, we are only going to reject the null hypothesis if this p-value is less than 0.05, and it certainly is not. The z-statistic is 0.6. We're looking at a z-statistic having to be somewhere between 2 and 3 to be statistically significant. Long story short, we don't have any evidence that it's not 50%. We're going to fail to reject. No, we don't have evidence. We're not rejecting the null hypothesis. Let me say this correctly. This says we cannot go with the alternative. We cannot reject the null hypothesis. We're not going to contradict John. It could be that 50% of the first-time weddings that is 50% female and 50% male. Be careful of your wording. You never accept the null hypothesis. You simply fail to reject it. Never use the word accept. Fail to reject the null hypothesis. It could be true. What John is saying is possible, and we're not going to contradict him. So John can rest assured that he's not contradicted. Okay, let's look at the last example here. Marketers believe that 22% of adults own a cell phone. This marketing company has that figure in mind as the true percentage of adults who own a cell phone. But a particular cell phone manufacturer believes that it's lower than the 22%. He did a survey with 174 Americans, and out of 200, and 174 had a cell phone. So what's our null hypothesis? We're going to go along with the marketing firm. Unless we have some good evidence, we're not going to contradict them. Okay, we're saying, okay, it could be 0.2, it could be 92%, but I really think it's lower. So again, how would that work in StatCrunch? We would again be under proportion stats, one sample with the summary. And let me pull the PowerPoint up again. 174 out of 200. 174 out of 200. Okay, let's get back to StatCrunch. 174 out of 200. And he thinks, let's get back to the PowerPoint again. He thinks it's 92%. He thinks it's 0.92. And we think it is lower than 0.92. So we're running a hypothesis test now, not establishing a confidence interval. And so we're going to compute. And this is a huge success because the p-value is a lot less than 0.05. Okay, and it's negative, which means that that it's less than, so it's less than, which means it is less than 92%. So how are we going to phrase this? We are going to reject the null hypothesis and claim that fewer than 92% of Americans own a cell phone. And we're going to put a little p-value next to that. And the p-value is 0.005. So when you reject the null hypothesis and you go ahead and you say the percent is less than 92%, you have to tell the public how confident, how sure you are of that. And that's what the p-value says. It says, I could be wrong in rejecting the null hypothesis, but the probability of error in my statement is only 0.005-ish. That's pretty small. Okay, so you're making a bold statement with a low probability of that statement being incorrect. Actually, if we have time here, it would be fun to edit and get a 95% confidence interval. Let's just see what's happening here. What percent do own cell phones? Between 82 and 91. Guess what? All of those numbers, 82% and 91%, are below his estimate or quote of 92%. So what are we? 95%. We can be 95% confident that somewhere between 82% and 92% of Americans own cell phones. So we could, and when you're phrasing a confidence interval, you always start with the phrase, we are 95% confident. That's the way to go. Okay? That, and then mention who? Americans. Do what? Own cell phones. What about American owning cell phones? Only 82 to 91% of Americans own cell phones. Okay, I don't think I have anything more to offer you. I hope that's enough. So we've got a couple of good examples here of cases where you do not reject the null, one you do not reject the null hypothesis, one you do, and then another one that's just a bold-faced confidence interval. While we have the confidence interval up, there will be times, aka homework, where they will ask you for the margin of error. And all they'll give you is the confidence interval. Well, how are you going to do that? You're going to say, wait a minute. The confidence interval is how wide? Well, I can measure the width, and then I can divide it by 2, and that's the margin of error. So even without knowing a lot of particulars, if you know the confidence interval and you take the upper boundary minus the lower boundary, take the difference, that's the width of this interval, the total width of the interval. And then if you want the width of half of it, that's the margin of error, and that would be 0.16. And you could say with 95% confidence, we can estimate the percent of college students that smoke accurate within 16.8%. So I'm going to save this video and post it, and it would be a good idea to review it because there's a lot of stuff going on here. I hope this video helped, and that you'll take notes and use it when you have to use it. Okay. See you later.